Charging a capacitor. Today we are going to look at the variation of current and voltage with time for a charging capacitor. In our circuit we have a power supply, we've got a 10 kilo ohm resistor, a 4700 microfarad capacitor, a voltmeter to measure the potential difference across the capacitor, and an ammeter to measure the current through the circuit. We also have a stop clock to enable us to take readings of voltage and current at regular time intervals. First, we will ensure the capacitor is fully discharged by connecting its terminals. This allows charged particles to flow between the capacitor plates to ensure that the net charge is zero and is therefore discharged. Then we can connect up our circuit. We will record the voltage and current in 5-second intervals, taken from the point the power supply is turned on and the capacitor is charging. I will record this data off screen and display it on screen afterwards. So I'm going to start the stop clock as soon as the power supply is turned on. Notice how the current is falling and the voltage is rising. So we should have enough data collected to analyze how the voltage and the current changes in a charging capacitor circuit. So here's our table of results. Note that as time moves on, the current decreases and the voltage increases. Now let's plot these results in graphs to have a better look at what's going on. Firstly, current. We can see that current decreases over time, but not in a linear fashion. Decreases at a larger rate earlier in the experiment and decreases at a smaller rate later on in the experiment. This is shown by the curve of best fit. Conversely, if we look at the graph of voltage, it increases over time, but again, not in a linear fashion. The voltage is seen to increase at a greater rate near the beginning of the experiment and at a smaller rate later on, as shown by the curve of best fit. For both current and voltage, the rate of change shown by the steepness of the curve is largest near the beginning, so it's largest here, and decreases over time until the end of the experiment. However, we have current decreasing and voltage increasing. So we have current decreasing and voltage increasing over time for a charging capacitor circuit, but the rate of change of both is greater at the start of the experiment when compared to the end of the experiment.